unlike a strong acid, a weak acid does not completely ionize, and that's because its acid dissociation or ionization is reversible. In other words, sometimes the ions go back together and form the unionized acid. So, of course, that means there's an equilibrium, and we could have an equilibrium constant, and we use Ka for acid, but it's the same thing. We have products over reactants, so it will be ions on top. And then underneath we're going to have the unionized acid. And we leave water off because water is a solvent, its concentration is considered constant during the reaction. And so of course we can do the same kinds of problems where we go between our equilibrium constant, so this is like our Kc, and we can use a Rice table and the expression for Ka to find this would be an equilibrium concentration. And now we also know how to take that and get pH. And you can do this both ways. If you're given a pH, you can calculate an equilibrium constant, which allows you to calculate your Ka. But anyway, then there's the general equation. This little part I'll show you, it basically just, the assumption you're making is that the acid is not very ionized at all, a very, very, very small percent. And that's generally true when the Ka is really, really small. The reason that you might want to assume this is that it will allow you to avoid a quadratic equation in your solving for your when you do your Rice table. Anyway, I'll show you, and you don't have to make that assumption when you get there. I'm going to look at bases before we do some calculations. So there are weak bases as well, and nitrogen forms a lot of weak bases. It has a lone pair on the nitrogen, so it has 3 single bonds to hydrogen, and then it has a lone pair. That lone pair of electrons forms a hydrogen bond with a hydrogen on water, and then sometimes the hydrogen just leaves and goes with the NH3. This is ammonia, the base, and this is ammonium, the polyatomic ion. Anyway, the Kb, now we know for base, is going to be the ions on top. Again, leaving off water. And then when you see a Ka or a Kb, the ions are on top, and so the stronger the acid is, the higher this number will be. So in this case, a base, if we have a weak base, we're going to expect a smaller Kb because we're going to have fewer ions.